Now in this video, we are going to implement the methods that we have explained in our previous lecture. So here, the first thing that I'm going to do, I'm going to create Q class. So I'm going to add new file and name it Q array. So because we are going to create Q based on array over here, so I'm going to declare our class over here. So it's going to be like this, public class Q array. Now inside this class, the first thing that we are going to do, we are going to declare our array, and we are going to declare top of Q and beginning of Q. So the array will be the type of integer, so that's why I'm declaring it like this. It's going to be ARR, and variable of top of Q will be the type of integer, top of Q, because in this variable we are going to store the index of the cells. So the second variable will be beginning of Q. So this one also will be the type of integer. Then inside constructor, we are going to instantiate our array with the size that we are receiving from the constructor, and we are going to set the top and beginning of this Q to -1. So our constructor will be like this, public Q array, which will take as a parameter size. Then we are going to instantiate our array, so it's going to be like this, ARR equals new int with the size that we are receiving, and we are going to set top of Q to -1 and beginning of Q to -1. So it's going to be like this, -1 and beginning of Q will be -1. Then at the end, we are going to print to the console saying that the Q successfully created with this size over here. So we are going to print out saying that the Q successfully created with size of this size over here. Now with this, we have successfully created our Q. Now if we call this class over here, our Q will be created in the memory. So inside main class, I'm going to create this Q over here. So what I'm going to do, I'm going to create the instance of this Q class. So it's going to be like this, new Q, and we are going to set it to new Q array over here. Now if you do so and run our code, you'll see that our Q is successfully created in the memory. Now here we have forgotten to put size over here, because when we are declaring the Q, we need to put size over here. So for example, if I put 5 and run our code again, you'll see that the Q successfully created with the size of 5 over here. So our Q is successfully created in memory. Now let's look at the time and space complexity for this Q over here. Now when we are creating Q, we are just instantiating the array in the memory. So this instantiation will take O1 time complexity. Then we are setting top of Q to -1 and beginning of Q to -1. So these two lines of code also will take O1 time complexity. Then at the end, we are printing out to the console this message. And this one also will take O1 time complexity. Now if we combine all these complexities over here, we will get O1 time complexity. Now the space complexity is On, because here when we are creating Q, we are instantiating in the memory n size of array. So this means that it's going to create in the memory contiguous number of cell that we have created based on this size over here. So if we put size 5, so it's going to create 5 contiguous cell in the memory. So this takes space in the memory, so that's why it takes On space complexity. Now after creating our Q over here, we have to insert some elements to this Q over here. And we know that in case of Q, for insertion we are using enQueue method. Now before creating enQueue method, I'm going to create isFull and isEmpty method, because we can use these methods inside enQueue and dequeue methods. That's why I'm creating these methods before them. So here, how can we identify that if this Q is full or not? Now we know that if we reach the size of this array over here, this means that the Q is full. So every time when we are setting new element to this Q, we are going to increase the top of Q. So that's why if the top of Q is equal to array length -1, this means that in this case our Q is full. So that's why I'm going to declare our method like this. Public is full, so it's not going to take any parameter, and here it should return boolean value, because if it is full, it's going to return true, otherwise it's going to return false. So here inside this function, we are going to check that if top of Q is equal to ARR length -1, in this case our Q is full, so I'm going to return true, otherwise I'm going to return false, else I'm going to return false, because in this case, if the top of Q is not equal to array length dot -1, in this case it means that we have still empty cells in our Q, so this means that our Q is not full in this case. Now with this, we have completed our method. Now let's see how this is working for the queue that we created in our main class. So here we have created an empty queue. So what I'm going to do over here, I'm going to check that if this queue is empty or not. So to do so, I'm going to create Boolean variable over here, and it's going to be result. So I'm going to set the value that we are receiving isFull method to this result variable over here. So it's going to be like this: new queue dot isFull. Then after calling this method, I'm going to print out this result variable to the console to see what's going to print out to the console. Now after doing so, if I run our code, you'll see that in this case it returns false, because in this case our queue is empty, so that's why it returns false. Now let's look at what's the time and space complexity for this method over here. Now it's obvious that the time complexity is O1, because here we are just checking the top of the queue with length -1, and based on that we are returning true or false. So these lines of code will take O1 time complexity, so that's why the time complexity for isFull method is O1 in this case. Now the space complexity is also O1, because in this case an extra space is not required to perform this operation. Now the next method that I'm going to implement is isEmpty method. So here let me just put isFull. So here this method is responsible for checking that if our queue is empty or not. So how can we check that? Now as you remember, when we are creating queue over here, we said that we are setting the beginning of queue to -1 and top of the queue -1. So if the beginning of queue is -1 and beginning of queue is equal to the length of array, because when we are going to dequeue the elements from this queue, we are going to increase the beginning of the queue. So that's why it might reach to the case that which is greater than the length of array. So in this case it means that our queue is empty. So this means that I'm going to check that if the beginning of queue is -1 or beginning of queue is equal to the array.length, in this case I'm going to return true, because in this case our queue will be empty. So I'm going to declare our method like this: public boolean is empty. Then we are going to check the first if condition. If beginning of queue is equal to -1 or beginning of queue equals arr.length, in this case I'm going to return true. Otherwise I'm going to return false, because in this case our queue is not empty. Now what I'm going to do, I'm going to run this method for the queue that we created over here. Now we know that the queue that we created over here is empty, so this means that this method that we are calling over here must return true, because in this case our array is empty. So instead of isFull method, I'm going to call isEmpty method and printing out result to the console. Now let's run our code. You'll see that in this case it returns true. This is because our queue over here is empty. We have just created our queue over here and we have not inserted any element to this queue, so that's why isEmpty method returns true. Now let's see what's the time and space complexity for this method. Now it's obvious that the time complexity is O1, because here we have just if condition, and based on this if condition we are returning true or false. And space complexity is also O1 because here we have not performed any space consuming operation. So that's why space complexity is O1. Now after this method, I'm going to create one of the main method, which is enQueue method. So this method is responsible for inserting elements to our queue over here. Now I'm going to declare our method like this. So our method will not return anything, so that's why I'm putting void over here, and the name of method will be enQueue. So as a parameter, it's going to take integer value, because we are going to take the value from here to insert to our queue. So here let me just put enQueue. Now inside this method, the first thing that we are going to check if our queue is full or not. So if it is full, we cannot insert any element, so we are going to return a message saying that it is full. Otherwise, we are going to continue to insert elements to our queue over here. So the first condition, if condition, will be like this: if is full, then we are printing out saying that the queue is full. Otherwise, we are going to check that if this queue is empty or not. So if this is empty, it means that we need to initialize the beginning index. Otherwise, if we have some elements in our queue, in this case, we don't need to initialize the beginning of queue. So in the else condition, I'm going to put like this: else if, so the condition will be like this, is empty, then in this case, we have to initialize the beginning of queue. So this means that beginning of queue will be set to 0, because when we are enqueuing the elements to the queue, we are just changing the top of queue. We are not touching the beginning of queue. But if the queue is empty, we have to touch the beginning of queue, because in this case, beginning of queue will be the first cell, so first cell's index is 0. But when we are initializing the queue, in this case, the beginning of queue is -1. So that's why we have to set it to 0. Then we are going to increase the top of the queue. So in this case, top of the queue increased by 1. Then based on this top of queue index, we are going to update the value of cell in the array. So it's going to be like this. ARR top of queue will be updated to value. And then after doing so, we are going to print out message to the console saying that this value is successfully inserted in the queue. So it's going to be like this: system out print successfully inserted value in the queue. Now after doing so, in this case, we have successfully inserted the first element in our queue. Otherwise, if we have some elements in our queue, in this case, we are not going to touch the beginning of queue. We are just going to increase the top of queue and updating the value of queue over here. So this part will be the same. So that's why I'm going to just copy it from here and paste it inside this else condition over here. So this part will remain same. Now with this, we have successfully completed enQueue method. So basically what we are doing over here is we are checking that if the queue is full, in this case we are not inserting anything, we are just printing out to the console saying that the queue is full. Otherwise we are going to check that if the queue is empty, this means that we have to instantiate the beginning of queue. So we are going to set beginning of queue 0, then we are going to increase the top of queue by 1, and we are going to update the new top of queue with the value of this value that we are getting from the parameter. Now in the else condition, everything remains same, except we are not updating anything in the beginning of queue over here. Now with this, we have finished enQueue method. Now let's see how this is working in practice. So here we have created our queue over here. Then I'm going to insert some elements over here. Now instead of creating size of 5, I'm going to put 3 because I'm going to insert some elements to see that when we reach the capacity of the queue, what will happen. So in queue, for example, I'm going to put 1. Then I'm just going to copy this from here and paste this few times. Now the capacity of our queue is 3. Now here I'm trying to insert 4 elements. So I'm just going to delete this part and run our code. You see that first element is inserted in the queue, and it says that successfully inserted in 1 into queue. So then successfully inserted 2 into queue, it is coming from here. Then successfully inserted 3 in the queue. Then when we reach the capacity of queue, it says that the queue is full. So this means that we cannot insert more than the size of the queue. So we have set the queue size 3. We can only insert only 3 elements to our queue over here because the size is fixed in this case. Now this is how enQueue method works in practice. Now let's see what is the time and space complexity for enQueue method over here. Now as always, we are going to start from the first line of this method over here. Now in the first line, we are checking that if this queue is full or not. So this part of code will take O1 time complexity. Then if it is full, we are returning the queue is full message to the console, and this one also will take O1 time complexity. Now in the else if condition, we are checking that if this queue is empty or not. So isEmpty method takes O1 time complexity, so this line of code also will take O1 time complexity. Now inside this else condition, we are setting beginning of queue to 0 and increasing the top of queue by 1. So this means that these 2 lines of code will take O1 time complexity because these are just 2 assignment statements over here. Then we are updating the array cell. So based on this top of queue index, we are updating the array cells. So we know that to update array cell based on the index takes O1 time complexity. So this will take O1 time complexity. Then we are printing out message to the console. So this will take also O1 time complexity. Now in the else condition, we are doing same operations over here. So these lines also will take O1 time complexity. Now if we combine these complexities over here, we will get O1 time complexity. Now the space complexity is also O1 because here we are just updating the value of cell in the memory. So an extra space is not required here to perform this operation. So that's why space complexity is O1. Now with this, we have come to the end of this lecture. So in this lecture, we have performed 4 methods of queue, which are creation of queue, isFull method, isEmpty method, and enQueue method. Now in the next lecture, we are going to implement other methods that we discussed in our previous lecture. So see you in the next lecture.